All right. Hey, good morning, everybody. Um, Welcome to December, December 1. Um, wow. All right. Couple of things. Number one, I want to make sure that we are okay with assignment 23. We left off on Monday in the midst of problem number 4. Problem number 4, yes. And I'm ready to pick up right where we left off, if necessary. Um, and then um, at either today or Friday, we're going to start with um, looking at assignment 25. Now, I don't have any notes or as far as lecture videos for assignment 25, so we're going to do an in-class lecture. Um, and so I'd like to get started with that today, but as I said, I want to make sure that we are um, good with assignment 23. So, um, to the person that, or to the students that asked about problem number 4, um, from assignment 23, that's the one that we got started working with. We didn't get all the way through it. Um, do we need to pick up where we left off, or are we good with assignment 23?
I got it. Thank you.
Y'all, you got it?
Yes, sir.
All right, what about the rest of the problems on the homework set? 5, and then after 5, um, we have some, um, just some review problems. Is there anything else from assignment 23 that anybody needs to look at? So I see a thumbs down. So does that mean that you're good with assignment 23?
Yes, sir. We're good.
Okay. Well, Sudan, have I heard from y'all? How are y'all doing with assignment 23?
We're doing good.
Okay. Do you have any questions over assignment 23?
No, we'll be okay.
Okay. Well, if that's the case, what I would like to do is I would like to start going over assignment 25. Um, so I sent out yesterday an announcement that I have notes made for assignment 25. Um, have y'all had a chance to print out those notes?
We're about to go print them right now.
Okay. Um, well, I'll just give y'all a little bit more time to go get those printed. Let's. I want to do a quick check. Um, okay, I got the Blackboard assignment up. Um, so I've got some grading to take care of. I know that. Um, and um, starting, if anything, excuse me. Starting with week 12, any homework or quizzes that we do, they're bonus points towards your homework slash quiz average. So I haven't done any grading since week 13, maybe even before that. Week 12, I don't know if we had anything. But anything that you turn in is going to be bonus points so long as it's complete and done just as you would normally do things, but everything will be bonus points from here on out in terms of your homeworks and your quizzes. So that will improve your grade slightly, but there are some extra points there. All right.
Mr. Clopton,
Yes, ma'am.
on week, what was it? 13, on assignment 22 for last week,
Yes?
I'm able to write now. Is it okay if I turn that in late?
Okay, so I'm talking to Liseth. Yeah, just let me know, get it to me as soon as you're done. So, did you get your cast taken off?
Yes, I did. I was on a splint for 10 days, and now they didn't put me on a cast or anything, so.
Well, that's good. Glad to hear that. So, are you going to be back to playing basketball anytime soon?
I start therapy Monday, and I go back to the doctor the 27th, and I should be released January.
Okay, cool. Well, I'm glad to hear that.
Thank you.
All right. Yeah, so as far as that, just get it turned in to me as soon as possible, please. All right. And since I haven't graded anything yet, I probably won't count it late because I haven't graded anything yet. All right, let's talk about assignment 25. There's 13 examples, I think. I don't know if I'm going to get to all 13 examples. I'm probably not. I think that once you see what we're doing, you'll get the idea. So in this assignment, we're going to be talking about two different concepts. Nonlinear systems and systems of inequality. So let's just start off by talking about nonlinear systems. A nonlinear system is going to be a system of equations that contains at least one equation that cannot be expressed in the form ax plus by equals c. This would be a linear equation. So we're going to have other types of equations happening here. So you can see right here, for example, this equation right here is linear, but this equation right here would be quadratic. We have a linear equation and a quadratic equation. We're going to talk about how do we solve this type of system. Over here, here we have another quadratic equation. Why do we know that's quadratic? Because the x is being squared, and the y is just to the first degree. And here we have a circle. So how are we going to go through and solve these nonlinear systems? Well, you can read through this little paragraph right here, but we're essentially going to be using the processes of substitution and the addition method. And the other and if we have time, we will take a look at some of the graphs of these systems so that we can visualize our solution. So let's just get started with this first example. I'm not going to tell you how to solve this system. I'm not going to say use substitution or use addition. You need to make those decisions for yourself. Um, but I'm going to help you out along the way. Um, so I, like I normally do, I like to label my equations, equation 1 and equation 2. And I want to think about how to solve this system. Now, one thing that I want to avoid is I want to avoid, if I can, plugging things into this x that's being squared. Because that's just going to create a lot of extra work for me. So what can I do besides substituting into x squared? Well, if I take a look at equation 2, I notice that the coefficient in front of my y is a -1. It would be really easy to get the y by itself here in equation 2. So I'm just going to rewrite equation 2. And I'm going to attempt to solve for the y. So if I'm going to solve for the y, I need to subtract the 3x. And then I need to get y by itself. How do I get y by itself? I'm going to multiply through by -1, and we get y is equal to 3x minus 9. Now what I can do is I can take this and I can substitute into equation 1. We're going to go back to the other equation and substitute in. So the other equation, equation 1, we have x squared is equal to 2 times y plus 10. Well, what we can do is we can take this expression for y and we can plug it in with this y right here. So let's see what happens. That's going to give us x squared is equal to 2, open parentheses, 3x minus 9, close parentheses, plus 10. We can distribute the 2, so that's going to become x squared equals 6x minus 18 plus 10. And now what we have is we have a quadratic equation. Well, we know how to solve quadratic equations. We solve quadratic equations by setting the equation equal to 0. So if I set this equal to 0, I have x squared. I'll subtract 6x. Now, -18 plus 10 is going to be a -8. And then if I add that to the other side, that becomes plus 8 is equal to 0. And then we can factor this. Well, what are the factors of 8 that add up to -6? How about a -2 and a -4? Which then, if we set each factor equal to 0, we then get that x is equal to 2 and x is equal to 4. So from here, we get two solutions for x. We have two solutions for x. Now, what that's going to mean for us is for each of these values of x, we're going to have to go and find the corresponding value of y. So, just so you know, yeah, I could probably be writing a whole lot bigger here. I could be writing bigger. Sorry that I'm writing so small, but you should have plenty of room to fit all of this work in this big space. You can see that I fit all that work in just a little bit of space here. Anyways, so here's what we're going to do. For x equal to 2, we need to go through and find y. Now we have this really nice equation for y right here. we know that y is equal to 3x minus 9. So then we could say that y is equal to 3 times 2 minus 9, which means that y is equal to 6 minus 9, which then means that y is equal to negative 3. So we have a solution of 2, negative 3. I'm just going to highlight that for just a moment. That's one solution. Now remember, there's two values of x that we got. So that means we have to go through and do the same thing for x equal to 4. So for x equal to 4, we need to find y. Y is equal to 3 times x minus 9. So that's going to be y is equal to 3 times 4 minus 9. Y is equal to 12 minus 9. Y is equal to 3. And so then we get the solution for 3. Now, it's always a good idea to take some time to check your answers. So I'm just going to go through and do this mentally. We're going to plug in these coordinates, this ordered pair, each of these ordered pairs into equation 1. Let's do it with me. If I plug in 2 for x, 2 squared is 4. Keep that in mind. Now, y is negative 3, so 2 times negative 3 is a negative 6. Negative 6 plus 10 is a positive 4. Positive 4 equals positive 4. Check. Let's check for 3. X is equal to 4. 4 squared is 16. Y is 3. 2 times y is 6. 6 plus 10 is 16. 16 equals 16. Check. So our solutions plural, we have two sets of solutions here. I don't need to put that in parentheses. Solutions. We have 2, negative 3, and we have 4, 3. Now, checking your answers is a great way to verify that you did the work correctly. I'm going to take a little bit of time right here to just show you that you can also take a look at the graph of these to verify your work. I think I'm just going to use Desmos to do this. So, that first equation that we had was x squared was equal to a 2y plus 10. And the second equation that we had was 3x minus y was equal to 9. So, there, can you see the parabola from the first equation? That was a quadratic equation. The second equation is linear. And you can see right here, when we take a look, there are two places where these graphs intersect. The first one is at 2, negative 3. I know that you can't see that. Even when I zoom in, it just stays the same size. Sorry about that. But that's 2, negative 3, and up here is at 4, 3. And so that is the solution. We're looking for where these two graphs intersect each other. Okay, so let's do another example. Any questions over example 1? Okay, let's do the next example. Let's see, do I want to do that one? Let's do one more. Here we have a, this is going to be linear. We have a linear equation. And right here, because it's x is being squared and y is being squared, we have a circle. So when I think about the possibilities here, I mean, I have a circle. We could have two solutions. I could have one solution where the graph does that, or it could be the case where we have no solution, a circle and a line out here in space. Um, I see up to three possibilities here for what kind of solutions that we're going to get. Let's see what happens. For this one again, I think I'm going to use substitution because um, it's really easy to get x or y by itself. Unfortunately, I'm going to have to plug into these x minus 2 squared or y plus 3 squared, but that's just going to be the best way to do this problem. So for equation 1, I have x minus y is equal to 3. This is where you get to choose what you want to do. I think it's just easy to get x by itself by adding the y to both sides. So we have x is equal to y plus 3. Then I'm going to hop on over here to equation 2, and we're going to substitute this into equation 2. So we get x, so that's going to be y plus 3 minus 2, quantity squared, plus a y plus 3 quantity squared is equal to 4. So you see that, hopefully everybody sees that the y plus 3, which is x, got substituted in right there. Alright, so let's do some work. 3 minus 2 is going to be 1. So we have y plus 1 quantity squared plus a y plus 3 quantity squared is equal to 4. Now you got to go through and FOIL this. You have to think of this as y plus 1 times y plus 1 and then y plus 3 times y plus 3. Because I know my patterns, I know this comes out to be y squared plus 2y plus 1 plus y squared plus 6y plus 9 equals 4. The expansion of this becomes that trinomial. The expansion of this becomes this trinomial. Alright, let's do some combining like terms. I have a 2y squared. 2y plus 6y is an 8y. 1 plus 9 is 10, and that's equal to 4. What do we want to do next? We want to set this equal to 0 because what we have right here is a quadratic equation. So now quadratic. Alright, I may have to start writing smaller to fit it in here. So we're going to subtract the 4 on both sides. So that's going to go 2y squared plus 8y plus 6 equals 0. And we need to factor this. We need to solve this. Well, I like the fact that every single term is divisible by 2. So I can factor out a 2. Which then this factors really nicely. What are the factors of 3 that add up to 4? How about a y plus 1 and a y plus 3? And since this is set equal to 0, all I have to do is set the y plus 1 equal to 0 and the y plus 3 equal to 0. And that leads us to the conclusion that y is equal to negative 1 and a y is equal to a negative 3. Alright, so again we have two values for y. So I suspect this is a situation where we have a circle with a line crossing through that circle, intersecting at 2 points. So we got to go forth and find the corresponding x values for each y. So for y equal to -1, I have this really nice equation for x. X is equal to y plus 3. That means that x is equal to -1 plus 3, which means that x is equal to 2. So we have the solution -1, 2. Or excuse me, yeah, -1. Say it correctly. 2, -1, excuse me. X comes first. And then we have to do the same thing for y equal to -3. X is equal to a y plus 3, so x is equal to -3 plus 3, which means that x is equal to 0. So we have the solution 0, -3. Now before I move on, I want to just double check this real quickly. So let's check it in the quadratic equation, or excuse me, the circle equation. X is 2, y is -1. So 2 minus 2 is 0, 0 squared is 0. -1 plus 3 is 2, 2 squared is 4, 4 plus 0 is 4, check. Let's check 0, -3. 0 minus 2 is a -2, -2 squared is a +4. -3 plus 3 is 0, 0 squared is 0, so 4 plus 0 is 4, check. So here are our two solutions. Let me write that out. Solutions. -2, or excuse me, +2, -1, and 0, -3. Cool. Any questions so far? Thumbs up if you're good. Thumbs up so far? Good. All right, let's do another one. Then we may move on to a different topic. Here we have this is actually going to be an ellipse. We can look at the graph of this one in a second. And this one's going to be a circle. The reason that this is an ellipse is because we have this coefficient of 4 in front of our x squared. Here's equation 1, here's equation 2. And I'm looking at these two equations, and I really like the fact that the y squareds both have a coefficient of 1. So I'm thinking that if I eliminate the y's, all I'm going to have is x's. So this is what I did, and you can write this out differently. You can do, there's a couple of variations on your instructions here, but I'm going to take equation 1 and add it to -1 of equation 2. So 4x squared plus y squared equals 13. We're going to multiply equation 2 by -1, so that's going to be -x squared minus y squared minus 10. And we're just going to combine these two equations together. 4x squared minus 1x squared is a 3x squared. The y's cancel out. And 13 minus 10 is a +3. So now I'm going to go through and solve for x. Alright, to start off solving for x, I'm going to just divide both sides by 3, so that leads us to x squared is equal to 1. Then, if you square root both sides, make sure that you include the plus or minus sign, so this leads us to the conclusion that x is equal to plus or minus 1. So again, we have two solutions for x. So for each of these solutions for x, we need to go through and plug them in to find out what y is. So let's just start right here. For x equal to negative, let's do positive 1 first. For x is equal to positive 1, what are we going to do? Y squared is going to be equal to 10 minus x squared. So I'm taking this equation up here and I'm getting y squared by itself. Let's hold off on the square rooting process just for a moment. So y squared is going to be equal to 10 minus a negative 1 or positive 1 squared. So y squared is equal to 10 minus 1. So that means that y squared is equal to 9. Which means then that y is equal to square root both sides, include the plus or minus notation, plus or minus 3. Whoa! Check this out. For x equal to 1, there's two possible values of y. This means that you have two solutions. You have 1, 3, and you have 1, negative 3. Now, we have only done the work for x equal to positive 1. We still got to go through and do the same work for x equals negative 1. So, for x equal to 1, we got two solutions. I wonder if we're going to get two solutions for x equal to negative 1. Well, let's go through and do the work. Y squared is going to be equal to 10 minus x squared. So that's y squared is equal to 10 minus a negative 1 quantity squared. Now, make sure that that negative 1 is in parentheses, because negative 1 squared is the same thing as 1 squared. That's going to be y squared is equal to 10 minus 1, which means that y squared is equal to 9, which means that y is equal to plus or minus 3. So we get two solutions here as well. We get the solution negative 1, negative 3, and we get the solution negative 1, positive 3. So how many solutions do we have here? 1, 2, 3, 4. In fact, if you go through and graph this, in fact, let's just take a moment to graph this real quickly. So that first equation was 4x squared plus y squared equals 10. 4x squared plus y squared, got my plus y squared equals 10. Oh, do you see our ellipse right there? There's our ellipse. And then the next equation was that equals 13. Let's change that real quickly, make sure we do it right. 13. And then our next equation was x squared plus y squared was equal to 10. And you can see here's our circle, here's our ellipse, and where do they intersect? 1, 2, 3, 4 places, and there are our 4 coordinates. there are our 4 coordinates. So, going back to our system, we can say that our solutions are, here we go, in no particular order, 1, 3, 1, negative 3, negative 1, negative 3, and negative 1, positive 3. There are our solutions. All right, problem number 4. I would say solve by elimination. I'll let you try this out on your own. I suggest that you eliminate the x squareds. I think that would be perhaps the easiest thing to do for this particular problem. Eliminate the x squares. And I want to make a note, and if we need to, we can come back to this on Friday. We want only the real solutions. We want only the real solutions. So, in this particular problem, you're going to arrive at some imaginary solutions. Okay? We're not going to include those imaginary solutions in our final answer. We want only the real solutions. Let's look at an application problem. Example number 5. You have 36 yards of fencing to build the enclosure shown below. Some of this fencing is to be used to build an internal divider. If you'd like to enclose 54 square yards, what are the dimensions of the enclosure? So, we are looking for, what we want to know is we want to know what is x and what is y. The dimensions of the enclosure. We want to know the length and the width. Now, all we know is this. First of all, let's start over here. The enclosure is to be 54 square yards. So that means that the area needs to be equal to 54 square yards. Well, what's our formula for area? Area is equal to length times width. So we're going to substitute x and y for our length and width. So area is equal to x times y, or 54 is equal to x times y. There's our first equation. The area of this enclosure is 54 square feet. Now, come back up here. We are only allowed 36 yards of fencing. Now, that 36 yards of fencing has to encompass the length, the width, the length again, the width again, and this divider. So, let's just take a time here to rewrite some things. I have x here, I have x there. This is y, and that's y. So what do we have? We have 2 x's plus 3 y's have to equal 36 yards. Or rather, 2x plus 3y has to equal 36. So here are our 2 equations. And let's just think about putting these 2 equations together. We have xy is equal to 54. And we have 2x plus 3y is equal to 36. And we need to solve this system. Now, you might say, well, can I solve for x in equation 1 or 2? Sure, why not? This is doing something different than I did. I just thought about this. Why not? You could solve for x or y even up here, but if I take a look at equation 1, or equation 2, equation 1, equation 2. We could move that y over to the other side, so that's going to be 36 minus 3y. Alright, we're about to introduce fraction, but we're just going to go with it. X is going to be equal to 18 minus 3 halves y. So that's what we have for x. Now I'm going to go over here to equation 2, where we have x times y is equal to 54. So that means that I'm going to replace the x with this 18 minus 3 halves y times y is equal to 54. Okay. So let's distribute the y. So that becomes 18y minus 3 halves y squared is equal to 54. Now, this equation right here is quadratic. That equation right there is quadratic. Now you tell me, what do you not like about this equation? You tell me, what do you not like about it?
The fraction?
The fraction. How do you, can we make the fractions go away here?
Yes.
How?
Multiplying by 2?
There you go. Multiply by 2. So distribute that 2 to everything. And then we get the equation 36y minus 3y squared is equal to a 108. Or rather, because I want to have that as actually, let's see what we can do here. I think we could divide everything through by 3. Make this even better. So that's going to become a 12y minus a y squared is equal to 108 divided by 3 is going to be a 336. Then, doing a little bit of rearranging, I'm going to move the y squared to the other side. I'm going to move the 12y to the other side. That's going to become plus 36 is equal to 0. And so, what are the factors of 36 that add up to negative 12? How about a negative 6 and a negative 6? Which then means that y is going to be equal to 6. So if y is equal to 6, let's just do some quick math here. X times y is 54, so x times 6, what times 6 makes 54? 9. So what are the dimensions of this rectangle? The x is equal to 9 yards and y is equal to 6 yards. Alright. Let's move on to the next topic of conversation. linear and nonlinear inequalities. So, um, this was meant to be kind of an initial review setup right here. If I were to graph x is less than 3 on a number line, if I make this 3 right here, if I were to graph x is less than or equal to 3, we would be graphing this shaded region to the left of 3, and we'd use a solid circle. So if x is less than 3, this is what it would look like on a number line. We know this. Well, what would this look like if you put this on a coordinate plane? Well, if this is 3, x equal to 3 looks like the vertical line through 3. And when we shaded less than 3, we had, 2, 1, 0, -1, -2, and so forth. That would be, these values over here on the number line, but since we're on a coordinate plane, we end up shading this whole entire, what's called a half plane of this coordinate plane. This is a set of ordered pairs that satisfy this inequality. So this blue area is all these points, all of these ordered pairs that are in this blue area, and there's infinitely many of them. All of those ordered pairs satisfy this inequality. So doing the same thing, what would it look like to graph and shade y is greater than -4? Well, y equal to -4 is a horizontal line through -4. Now, because it's strictly greater than, there is no or equal to, we're going to use a dotted line. So we're going to do a dotted line through -4. And x is greater than -4. So what's greater than -4? Or excuse me, y is greater than -4. What's greater than -4? -3, -2, -1, 0, all of these points. So we're going to shade this half plane. So we're going to be talking about how to solve inequalities on a coordinate plane. Alright, so let's look at our first example. Graph and shade y is greater than -2/3 x. So if I take a look at if I make this an equation, we know that this is an equation of a line, where we know that the slope, m, is -2/3, and my y-intercept, b, is at 0, 0. Now, because it's strictly less than, we're going to use a dotted line. So if I graph this at 0, 0, my slope is down 2 over 3, so we're going to go down 2 over 3. We can go up 2 to the left 3. I can draw a dotted line. Now the question is, what direction do I shade? Now, two ways to do this. One, you can take a look at this guy up here. If it's greater than, you're going to be shading above the x-axis. Another way to do this is to pick
Your conference is scheduled to end in 2 minutes.
So if I test a point like this, that's the test point 0, 2. If I test 0, 2 in my function, 2 better be greater than or greater than -2/3 times 0. Well, 2 is definitely greater than 0. Check. So this test point right up here tells me that my assumption is true that everything above this shaded region gets shaded. Okay. So we don't have time to do anything else. My plan is to make a nice version of my instructor notes, get those posted so that you can see what the rest of the notes look like. That way you can get started working on the homework. If that plan deviates, I'll let you know, but that's my plan right now. And so on Friday, if we need to pick up any questions, we will over the homework. And I think we should have a quiz on Friday as well. So be prepared for that. In that case, if there's nothing else I don't think there's anything else
Your
to talk
conference
about.
is now over. Goodbye.
I'll see y'all Friday. Take care. Bye-bye. Bye-bye. Bye-bye.